Okay, for this one, number 30, you should be able to complete the square to solve this guy, and that's how these guys are written in vertex form. But if you don't want to do that, so if you want to do that, do like we did on question 29. If you don't want to do that, you can read the difference between all these questions, and they're all in vertex form. It does have the correct value for each of them, so it has that the max is at 96 and 81, etc. So you can't just eliminate any of them by saying like maybe there's a minimum or something, but you could go ahead and actually graph it. Because I'm comparing two functions, I could just go ahead and plug it in. So I already went ahead and plugged in the original function, and I plugged in option B, so the one that has plus 81. And then when you graph it, just see what happens. So there's my original graph, and you can see that it has that dark line now. So that second graph is not actually lined up perfectly. You can also go to your table to look at your ordered pairs. I can see 32 and 17. So these are my x values, these are my y values. I can see that it does not work. Here's my first function, my original. It actually gave me all of my maximums. So I could just look and see if either of those are maximums. Well, I can actually see that negative 48, 32, 32. I can see that 96 is by itself, and that is going to be a maximum. So I know it's the first option. May not be as obvious just right off the bat, but I'm going to go ahead and change this negative 16x minus 1 squared to a plus 96. So I knew the first one was the correct answer, so I just skipped that one for a second. But now I've typed in the original function and the one that I know the correct answer. So when I go ahead and graph it, it should graph the same line twice. So there it goes, graphs the first line. And looks like nothing happened. But if I go to my table, I can actually see that for negative 2, the y value is the same. And the y is the same, and the same, and the same. So these actually lined up on top of each other. So those are the exact same function. And again, I can see that 96 is my maximum. So A is the answer for that one. Okay, for question 31, this one you can, when it has the multiple select, you got to kind of work your way through all of them. So I'm going to go ahead and just pick out some things I can spot that are easily wrong. So right here I have x equals negative 3 and x equals 5. So that tells me my intercepts. So that's these three right here. So if x equals negative 3, then x plus 3 has got to be a factor. And same thing for x equals 5. X minus 5 has got to be a factor. So this one right here is wrong because it's giving you those wrong factors. But these two guys are possibly correct because they both have that x plus 3, x minus 5. Next, I can easily erase some answers because of my vertex. My vertex is 1, 8. So that's going to be, and remember, it's always the opposite of how you expect. So it's not going to be plus 1 plus 8. It's going to be a minus 1 plus 8. So I can actually get rid of this as an option. This negative 1 and positive 8 is a possibility, and this negative 1 and positive 8 is still a possibility. Next, I can look at the 1, 3, 5 pattern. So if I look at all my multiple choice answers, I only have a negative 0.5 or a negative 1. Negative 0.5, negative 1, whatever. Also, they all are negative, so I can't eliminate any answers because I do know it's negative. But let's look at our pattern. Well, if I try to go down 1 over 1, and down 3 over 1, and down 5 over 1, or whatever, I can see that it is not a 1, 3, 5 pattern. So anything with just a number out front, like a 1 out front, is not going to work. So this guy, he's a 1, 3, 5 pattern, not going to work. This guy, not going to work. And this guy, not going to work. So that only leaves these three options. Well, this guy, and if you look at the pattern, it actually does go down 1/2 and over 1, and then down 1.5 over 1. So this guy has the correct x-intercepts, has the correct slope, or, not slope, but 1, 3, 5 pattern, so that guy works. This guy has the correct vertex, negative 1, 8. What it says minus 1, but it's really positive 1, 8, so that's correct as well. And this guy is not as obvious. This one you've got to do the negative b over 2a. When you do negative 1 over 2 times negative 1/2, you get 1. When you plug that back in, you get 8. So that does have that correct negative 0.5, 1.5 pattern, and has the correct vertex. So this guy is also correct. Number 32, if you read through the problem, has a width that is 5 less than the length. And here's my length. So draw a rectangle. You don't want to have different variables, so call one length, call one length minus 5. Most of the problems we do usually deal with the width, but this one just happens to be length, so no big deal. It says that the area of the rectangle is 126, So I need to set up an area formula. So area equals length times width. Well, if area is 126, I know 126. L is still L, and W is now L minus 5. This is just a basic quadratic. I'm just going to multiply straight through. So 126 equals L squared minus 5L. I want to set it equal to 0. You almost always want to set it equal to 0. That's the easiest way to solve most everything. I can't do square root method like that. So move this guy over. I get 0 equals L squared minus 5L minus 126. From here, you can do quadratic, whatever you want to. I'm going to go ahead and just factor. It's a pretty easy X method. What multiplies to be negative 26 adds to be negative 5. And that's going to be a negative 14 to positive 9. So I'm going to have L minus 14 and L plus 9. Set each of these equal to 0, so you get L equals positive 14 and L equals negative 9. Obviously, I can't have a negative 9 length, but I can have a positive 14 length. But then read the question. The question said, find the width of the rectangle. So I've got to go ahead and plug that back in. So the width was L minus 5, so 14 minus 5. So the width, the width is 9 feet. Number 33, they give you the area formula. They tell you the area is 32. They tell you B1 is H and B2 is H plus 8. So just plug those things in. So area is 32. The 1/2 does not change. The H does not change. But B1 was H and B2 was H plus 8. So just plug in what you know. And then work your way to cleaning it up and getting it equal to 0. So 1/2 times H times 2H plus 8. 32 equals, I'm going to multiply that H straight through. So 1/2 H times 2H is 2H squared. H times 8 is a positive 8H. I want to get rid of that 1/2. You could multiply it over here and get 64, but I want to go ahead and cut these numbers in half if possible. So 32, half of 2H squared is H squared. Half of 8H is 4H. Move your 32 over, and again, same thing we do repeatedly is get it equal to 0, and we're going to solve. Very easy X method. What multiplies be negative 32 but adds to be 4. That's going to be a 4 and an 8, and I want to have a negative 4. So 0 equals H minus 4, H plus 8. Set each of those guys equal to 0. H is going to equal positive 4. H is going to equal negative 8. Again, I can't have a negative 8 as a height for this guy. The question just said find the length H in inches. So I literally am just finding H. So there it is. And just add on the word inches. So H equals 4. Oops, a little bit off the screen there. Sorry. H equals 4 inches. Real quick, going back to question 29, I just realized I forgot to identify the max or the min. I was looking at the key and I saw I didn't do that. So question A, to figure out if it's a max or a min, look at your A value. So my A value is a 1, which means my graph opens upright. So I know it's going to be a minimum. And then my minimum is just that negative 3. Looking over here, this is a negative, so I know it's going to be opening downright. It's going to make it a max value. And my max value is, I must finish on another piece of paper. My max value is going to be 23. I must have finished this question on a separate sheet of paper. All right, question 34 shows you a graph of a girl diving off the diving board into a pool, and it's asking me certain questions. So what is the girl's initial height? You're just going to go on the graph, and at time 0, before she actually jumps, her initial height is up here at what looks like 45 feet. What is the maximum height of the girl? You're going to go to your vertex. This vertex looks like it's 0.549. So 0.5 means it took her half a second to get to the max height, and 49 is that max height. So what's the maximum height? That is going to be 49 feet. When did the maximum height occur? Well, I just said that it took her half a second to get up there. So it's going to be 0.5 seconds. And how long was the girl in the air before hitting the water? Well, this follows the height of the girl over time. So when she hits the water, her height is 0. So usually when things are like hitting the ground or hitting the water, or how long was something in the air, generally looking for a 0. So go down here and see what that guy is. And that guy looks like he's 2.25 seconds. All right, this next question, 35, is from chapter 13, which means that we solved most of these problems in the calculator. So I'll tell you about the math for each problem, but I'm going to be using the calculator to solve. On the key that you'll see later today, I did go ahead and work out everything by hand using the old method, but if you have a calculator and you know how to use it, you might as well use it on the test. All right, so here is an equation. A physics class built a device that launches a tennis ball into the air, so we know it's going to follow some curve like we just had on the previous question. It gave us the equation, so I'm just going to go ahead, and I already did. I went ahead and plugged that equation into my calculator, and I'm just going to graph it. Okay, so I see that it does follow that parabolic curve like I expected it to. I can't see the top of this graph, it's not that far away though. Like I know it's not terribly high up there. So I'm going to go ahead and go to my window, and I'm going to change my Y max to something higher. So I'm just going to try 20. I'm going to graph it again. I'm almost there, not terribly far away, so change my window maybe 25 or maybe 30. It doesn't hurt to be a little above. So I'm going to try 30. Okay, cool. So we actually got a little extra high up there, which is fine. We could just move it down, but no big deal. Either way, the question says approximately how long was the tennis ball in the air? Well, how long was the tennis ball in the air is asking when did that tennis ball hit the ground? So I'm looking for a 0. So I'm just going to scoot this a little bit over. I'm going to go find that 0. So I'm going to press second trace. I'm going to go down to 0. And my goal is to find this 0. So I want to be to the left bound of this 0. Well, my cursor's here. So I can actually press enter because I'm already to the left of that answer. Boom, press enter. Now it wants the right bound answer. Well, my answer's here, so I'm going to press the right arrow key until I get to the right of that answer. Also, when I go to the right of it, it's going to have a negative y value. So now I'm negative y value. Also, I can very clearly see I'm to the right of it. So now I'm right bound, press enter. When it says guess, if you want to move it, you can. You don't have to, though. Press guess. I get 4.27, blah, blah, blah. This negative 2e to the negative 12 is essentially 0. That's a scientific notation. It's just saying the answer is negative 0.000000002 or whatever, which is basically 0. Anyway, so 4.27. So this answer is 4.27 seconds. Okay, so that's that answer. The next question says, also to solve that by hand, you would set the equation that we typed in here equal to 0, and then you would do quadratic formula and solve it that way. Okay, the next question says, what is the maximum height of the ball? Well, that's a really easy question to do in the calculator. If I'm doing it by hand, I'm going to do negative b over 2a to find my x value, plug it back in to find my y value. Or you could complete the square. Either way, let's go ahead and find the max. It is a max because it's the highest point. So I'm going to press second trace. I'm going to go up to maximum. And I'm going to be, my answer's here. So I want to be to the left of my answer. So I'm going to press the left arrow key until I get to the left of that. Press enter. I want to be to the right of it. So press the right arrow key until I get to the right of it. Press enter. Guess. Just press enter. What is the maximum height of the ball? Well, it took 2.04 seconds to reach the max height of the ball, but the max height of the ball is 24.4. So 24.4 feet. Making sure that's right on my answer key. Yep. And on my answer key, I rounded to 4.1. So feet. All right, and then lastly for this question, at what time or times will the ball be 3 meters above the ground? So for this one, you're going to go to y equals, and if you ever want the height to reach a certain value, you just go plug that number in. So I'm going to plug in 3, and I'm going to graph it. And now I'm going to go second trace and see where it intersects. So second trace, I'm going to go to intersect. First curve, press enter. Second curve, press enter. Guess, it's already there, press enter. That's negative time. I don't want to have negative time. So clearly I want just this answer. So second trace, intersect, first curve, press enter, second curve, press enter. Guess, I'm actually going to go over there, close to it, press enter, and 4.13, that is the time at which the ball will be 3 feet high. So 4.13 seconds is that answer.